Hello friends, today we are going to see the derivative of exponential and logarithmic function. Exponential and logarithmic function. So in this part, first we will see what is meant by exponential function and logarithmic function. Okay. So first definition we are going to see for exponential function. See, if you get any function in the form of a to the power x, where a is greater than 1. Okay, any function if you get in the form of a to the power x, then that type of function is called as exponential function. Is called as what? Exponential function. And second one is what is meant by logarithmic function. If a to the power x is equals to b, if this is the condition, a to the power x is equals to b, then we define log x to the base a is equals to b. Log x to the base a is equals to b, and this is called logarithm of x to the base a. This is called the logarithm of x to the base a. Okay, so these are the two definitions of exponential function and logarithmic function. Okay, now under this we are going to see some rules, or you can say properties of logarithm. Properties of logarithm, that is, first property of logarithm, that is log of x into y. Log of x into y means this is the product of two functions, and if the log is there, then this can be written as log x plus log y. Log x plus log y. Second property, log of x by y is equals to log x minus log y. Log x minus log y. If it is a product, addition. If it is division, subtraction. Third, log of x to the power n can be written as n log x. Okay, so log x to the power n. So whatever the power is there, that power you have to multiply, and that log x you have to keep as it is. Fourth property, log x to the base a can be written as, okay, log x to the base b divided by log a to the base b. Means what we can do here, this log x to the base a. So this x already is a function, but here a is a base, but this a also we can consider as a function by considering the new base, that is b. Okay, you can take it any other base also. Okay, fifth property, log x to the base a is also written as 1 divided by log a to the base x. Log a to the base x. Next, sixth one, log x to the base x. Its value is always 1. Function base, if it is same, its value is 1. And log 1 value will be 0. Log 1 value will be 0. Okay, so you have to remember these properties. Okay, most probably useful properties are the first one, second one, third one, and I think this fourth one. Okay, so in this this first three are very useful while simplifying the examples by logarithmic method. Okay, now we will solve the examples of exponential function first. Okay, then we will solve some examples using logarithmic method. Okay, so let us see the examples on that exponential and logarithmic function. Okay, so here we have to differentiate all the functions with respect to x. Okay, so write differentiate with respect to x. Okay, in that first example, y is equals to e to the power minus x. y is equals to e to the power minus x. So when you differentiate this with respect to x, y derivative is dy by dx, which is equals to derivative of e to the power minus x is what? Minus into e to the power minus x. Means whatever the x coefficient is there, that we have to multiply and that derivative to keep as it is. Second one, y is equals to e to the power x cube. So again, y derivative is dy by dx, which is equals to derivative of e to the power x cube is e to the power x cube only into x cube derivative is 3x square, because this is a composition function. So derivative of exponential function is as it is into x cube derivative is 3x square. Third example, y is equals to e to the power sin inverse x. Again it is a composition function. So first y derivative is dy by dx, which is equals to derivative of exponential function is again same, that is e to the power sin inverse x into sin inverse x derivative is 1 divided by root of 1 minus x square. Okay. Next example, y is equals to cos inverse of e to the power x, cos inverse of e to the power x. So y derivative is dy by dx, which is equals to, this is composition function. So first we will take the derivative of cos inverse. So derivative of cos inverse x is what? Minus 1 divided by root of 1 minus x square. So minus 1 divided by root of 1 minus x square. But here x is what? E to the power x. E to the power x whole square into derivative of e to the power x is e to the power x. You can keep the answer as it is, or you can simplify. Minus 1 into e to the power x minus e to the power x divided by root of 1 minus, here e to the power x whole square is there, this 2 into x, the powers will get multiplied, e to the power 2x, e to the power 2x. Okay. Next example, I think sixth one, y is equals to root of e to the power root x, root of e to the power root x. So this is the composition of three functions. Okay, so let us find, say how we read this, root of e to the power root x. So first come root, second is e, and then again root. Okay, so y derivative is dy by dx, which is equals to, now first we take the derivative of root. Root x derivative is what? 1 upon 2 root x, but x is inside function, e to the power root x into, now e to the power root x derivative is e to the power root x into root x derivative is 1 upon 2 root x, 1 upon 2 root x. This is the derivative. If you want to simplify, you can simplify it. Okay. Next example, y is equals to e to the power x divided by sin x, e to the power x divided by sin x. Now this function, it is in the form of u by v, means it is in the form of division. So whenever the function is in the form of division, how we find the derivative? Using the product rule, using the, sorry, not product rule, using the quotient rule, using the quotient rule. So y derivative is dy by dx, which is equals to, what the quotient rule says, denominator square, so that is sin square x, then denominator is constant into derivative of numerator. What is the derivative of e to the power x? E to the power x minus numerator constant into derivative of denominator, sin x derivative is cos x. So here dy by dx is equals to, you can simplify. In this e to the power x is common, so what is left? Sin x minus cos x divided by sin square x, divided by sin square x. Okay, so this is the solution of this example. So let us see some more examples of this part, y is equals to sine of tan inverse of e to the power x, sine of tan inverse of e to the power x. So y derivative is dy by dx, which is equals to, again it is the composition of three functions. How you read this? Sine of tan inverse of e to the power x. So first function is sine function. So derivative of sine is cos this x as it is, that is tan inverse of e to the power x into, next derivative of tan inverse x is 1 divided by 1 plus x square, but here x is what? E to the power x. So e to the power x whole square into, okay, e to the power x derivative is e to the power x only. Okay, we can simplify. So this is e to the power x into 1 is e to the power x into this cos of tan inverse of e to the power x divided by 1 plus e to the power 2x, because the powers will get multiplied. Okay, next example, y is equals to e to the power x plus e to the power x square plus so on plus e to the power x to the power 5. Okay, so first you write the middle terms which are missing here. So e to the power x plus e to the power x square plus e to the power x cube plus e to the power x to the power 4 plus e to the power x to the power 5. So when you differentiate this, y derivative is dy by dx, so which is equals to e to the power x derivative is e to the power x plus e to the power x square derivative is e to the power x square into x square derivative is 2x plus e to the power x cube derivative is e to the power x cube into x cube derivative is 3x square plus e to the power x to the power 4 derivative is e to the power x to the power 4 into x to the power 4 derivative is 4x cube plus e to the power x to the power 5 derivative is e to the power x to the power 5 into x to the power 5 derivative is 5x to the power 4. Okay, so this is the solution of this given function. Let us see two more examples, so we can finish with this one concept. Okay, so y is equals to log x, y is equals to log x. So y derivative is dy by dx, which is equals to, what is log x derivative? 1 upon x. So therefore log x derivative is 1 upon log x, because the x place is taken by log x, into again this log x derivative is 1 by x. So this is the answer. Or you can write 1 upon, you can write this x first into log x. Next, y is equals to cos of log x plus e to the power x. So this is again composition function, cos of log x plus e to the power x. So y derivative is dy by dx, which is equals to, now first to take the derivative of cos, that is minus sine of log x plus e to the power x into log x derivative is 1 by x plus e to the power x derivative is e to the power x. So this is the answer here. Okay, so here I have solved maximum examples based on logarithmic and exponential function. So in the next video you will have the examples based on logarithmic method. Okay, thank you.